So, shall we start? Hello, everybody. It's DOTS working group session, and I'm sure everybody is tired. It's the last session of the week, but let's concentrate. So first, I'm your speaking head today because Frank worked so hard that he caught cold and get lost his voice. So I think he'll recover. We wish you.
Say 2 words. So can you hear me? So you know what happened. Yeah, it's very sexy. So I don't want to frighten you. So I try to keep silent, but if necessary, I still will comment something. Okay, so please forgive me this problem. Sorry.
So I'm your speaking head today. Well, so this is not well. Just I think everybody of you knows about it. Just to look again, it's IETF action. So all what you will say today is the subject for Note well. We have a couple of administrative tasks. Blue sheets are going around. I think there's someone in the room, and we need Java scribes and note takers. So, any volunteers? Okay, thank you. And the Java scribe. Well, a Java scribe. No volunteer?
Let me try if I can.
Okay, thank you. Work group draft status. So from the last meeting, we have some progress on the signal channel draft. It got stuck for quite a long time with discuss from transport area director, but recently there is some progress, and there was some suggestions from Karsten Bormann, and they were accepted by the draft authors. So I hope the draft will be progress after that, and it will be discussed today, the changes. Then we have 2 drafts, call home and server discoveries that have just passed working group last call, and they're waiting for write-up to be sent to ISG for publication. We've also have draft DOTS use cases and DOTS architecture that have already been sent to ISG. They're waiting for our ID to review them, and to move them further. So overall, there is some good amount of activity in the working group since the last session. So our agenda for today, we have several presentations. I think that we'll start according, well, any question about agenda? Any suggestions? Okay, then we start with DOTS telemetry relating hackathon activities. Yeah, sure.
I'm Kanami Nishizuka from NTT Communications. This weekend, I joined the IETF hackathon. Then I did things about the DOTS telemetry. Then the target was the telemetry draft written by Till and Meadow and other members. Then the target was preliminary implementation and POC of the telemetry. However, I found at that time that the draft needs a lot of clarification. So I've tried it, but at most, the most works at that time was a design review of DOTS telemetry. Then here is a brief summary of design of DOTS telemetry. The purpose is giving the maximum capability of conveying normal and attack traffic related metrics as a hint from a DOTS client to a DOTS server and DOTS server to DOTS client. So the timing of telemetry can be divided into these two timings. First one is pre-mitigation and the second one is post-mitigation. So for the pre-mitigation, what is the pre-mitigation? So the definition of pre-mitigation telemetry is here. Pre-mitigation resources are not bound to any mitigation request because it is before mitigation request. So your new URI path telemetry is defined in that draft. Then the first 2 points are telemetry config and total metrics can be set beforehand, so it will not be frequently updated. However, I found that attack detail can be updated more frequently because it is the update of current status of attack. So my proposal is separate the URI path of them into two so that update of attack detail doesn't always require configuration related update. So here's the proposal URI path. It indicates the telemetry config. So telemetry config includes the telemetry config itself and the total related metrics like baseline of the traffic and capacity, total capacity from viewpoint of DOTS client. So put, get, delete will work with like this written on the slide. Then theoretically it works well with TCID, telemetry configuration identifier. So in this spec, I dropped the attack detail. Then this will be in the separated URI path. But before that, I'd like to add a consideration related to machine learning approach. Machine learning approach is already written in the telemetry draft. However, the current specification only care about the first point. So sending the normal traffic baseline statistically calculated at DOTS client. However, the second one is more machine learning based approach, I think. And if you use the machine learning approach, DOTS client need to send the traffic metrics periodically to the DOTS server. Then DOTS server can do the statistical learning in order to learn the normal traffic or normal metrics of that telemetry metric. So in order to accomplish it, the requirement to the DOTS client is sending the metrics in periodic manner. So as a pre-mitigation URI path, I'd like to propose the normal traffic module in addition to attack detail. Then put and get and delete will be used for conveying the current information of attack and normal traffic from DOTS client. Then get and delete is so on written here. However, here is a note. So if DOTS agent send the traffic metrics, it needs to be compared with other approaches like the IPFix However, I think those metrics is worth to be conveyed in DOTS signal channel or data channel. Okay, Thiru.
Hey, Thiru, if we are relying on sending traffic metrics periodically, I suggest we rely on existing protocols like IPFix, and not reinvent something, right? The only reason why dot signal channel was picked because it would send the baseline behavior, what's normal behavior of the traffic that it would see in high, low, and medium percent profile. But if it is supposed to send traffic or performance metrics periodically, then we should be using other protocols like IPFix, which is already designed for that purpose. And most of the network devices support IPFix already, right? So if we want to use the telemetry details periodically, then if you see today, many of the network devices send IPFix traffic to DDoS detection system for identifying anomalous traffic, right? So I don't think we should be doing what IPFix is already doing in this draft.
Okay, partly I agree with that, but if it could be conveyed with DOTS channel, then it can be easily combined into the context of DOTS. So
Yes, through here, but it's not stopping us to use IPFix, right? I mean, IPFix also uses client-server authentication, and it's pretty much the DOTS client that can act as a client and send the IPFix telemetry back to the server, right? I mean to say, IPFix already gives a template for defining the telemetry attributes, the network attributes, and the template can be easily changed on the fly, right? IPFix has various advantages. We should not try to reinvent a new protocol for that.
okay,
Hakanami, I think Thiru's point makes sense. Sorry. So can I confirm to you that you want something like the IPFix telemetry can be also conveyed by the DOS channel protocol? Is that your intention, or?
yes. So I mean, in this normal traffic or normal connection, it conveys the statistical or some metrics measured on DOTS client side. So yeah, as you mentioned, it can be conveyed by IPFix if it is defined so.
If it's DDoS specifically related, maybe we can consider my personal idea.
Okay, thank you.
But we need to see what is the information you are talking about, or you want to convey by the DOS protocol. Because generally, I think I agree with Thiru that we do not need to reinvent the existing protocol. IPFix is very good, right? So we can discuss later. Okay.
Okay. Yeah. Thank you.
Sorry.
Yeah. That is my point. So thank you for the comment. Okay. Then from DOTS server to client, this doesn't include the normal traffic because attack detail will be needed to be conveyed. Then I also propose the separated URI path because these resources for the observation of the attack info stored in DOTS server side. So this would be can be also used for asynchronous notification to the DOTS client. Okay, then here is some scenario for you because some people might have a question that why server to client attack info in pre-mitigation stage is needed. So here is a scenario where DDoS attack happened. SOC, Security Operations Center at the client side can notice something going wrong, but cannot figure out which IP address is exactly attacked. So what if my suggestion is what if SOC at the DOTS server side can convey attack details to the DOTS client? Then finally, DOTS client can figure out which one is attacked. So then it can finally trigger the mitigation request. So this is the actual scenario heard from some SOC people. So this use case is worth to be considered.
Thiru, we have already updated the draft to accommodate this one.
Yep. Thank you. So post mitigation, here is a brief summary of post mitigation telemetry. However, current spec is enough to convey those parameters. So there is no update from my side. So then I'd like to introduce two considerations. So first one is about the percentile calculation. So percentile calculation requires these parameters. So one is period of time, and the second one is time granularity. And so if the dot client and dot server is not agreed on the period of time, then they can be misconfigured. So there should be an inconsistency before
Yeah,
picking them.
Thiru, that's a good one, Kanabe. I think that's I think you should raise a comment and we'll raise it as an issue and we will look into that. I think this is going to be really useful, especially for flash crowd attack scenarios, because flash crowd happens maybe once in a year or twice, and giving that period of time where the profile was generated is going to be really useful for the DDoS mitigator. And the granularity typically is probably for IPFix, I believe it's around 1 minute to 5 minutes. So we need to figure out the right parameters for the granularity. But period of time is how long you take to baseline the normal traffic behavior, and it could be weeks or months altogether. Okay.
Yeah. Thank you. Then about the terminology request, what I found was there is no exact definition of what the request is and what partial request is in current draft. But Till said to me offline that the partial request is characteristics of slow release. So Till is happy to update the draft in the next version.
We'll add a terminology for the partial request, what it means, what partial request means.
Yep.
Yeah, thanks.
Yep. Thanks. Okay, so this is the last point. So I'd like to do the brief sales update of interrupt. So actually, I and John have been conducting the continuous interrupt testing. So we found several bugs on both sides. However, this must be a good news that there is no significant issue on signal channel version 38 and the data channel 31, except one. However, the issue found in here was already addressed. So next version will cover this point. So there's no significant issue currently, I think. Then, maybe the next presentation will mention about the new heartbeat mechanism, but it will be introduced in the version 39 of signal channel draft. Then I and John are waiting to test the version 39. So as soon as possible, so it will be report back to the working group after that. Then finally, our Go.dots implementation is open source, so you can touch it and you can use it freely. And the Kubernetes deployment will be available soon. So that is the latest news from me. Thank you so much.
Any questions?
Wei Pan from Huawei. I have a question about your machine learning page. You can turn to that page. In this page, you mean that the DOTS client first calculate some traffic baseline information and send it to the server, and then server again use the machine learning technicals to calculate another normal baseline in the server side, right? Do you do that?
Okay, no, actually, current draft is doing the calculation of baseline on client side. Then
Yeah.
client only send the result of calculation as a baseline. So, however, this slide, I try to explain that the calculation on client side is not enough to do the actual machine learning approach because server side, you require the raw data of metrics in order to make modeling
Okay.
of those metrics in server side.
So you means actually the server, it's better for the server to collect the raw data to do the machine learning things by itself, not just by the client to do the machine learning and just send a few dates of the normal baseline traffic like that.
Yeah, right. So that is what I mentioned. So that is the point. So dot client has a limited, could have the limited resource of calculation, and also
Okay.
dot server itself needs to make its own modeling of normal traffic. So
Yeah. This makes sense to me, and I think maybe the authors can consider it. And also, do you by using the machine learning approaches, do you have some preference for? I'm not familiar with this kind of technology, so I don't know whether the information need to be conveyed is like common or kind of. We can't standardize it. Maybe you can offer some information on the mailing list. Okay.
okay, yeah, I can consider that, but
Yeah, I mean, when you use just for you use the machine learning approach. What kind of information you need, and based on what approach, some kind of background information you can share with us.
okay, yeah. Thank you.
Thank you.
Yeah, I'll write it on the mailing list.
Hey, Thiru here. I'm not opposed to the machine learning approach, but what I'm trying to say is that IPFix is already used by routers and DDoS mitigation systems and DDoS detectors for baselining and profiling. And since we would want to leverage an existing protocol and not reinvent something,
Yeah.
because this has been already done. There are products in the market which take IPFix data and do analytics on that. I can name few of them, but Arbo does it, Radware does it. So most of the DDoS mitigation providers who are doing it were doing that. So unless we have new requirements why this needs to be done in .signal channel, we should have a very strong reason for that, and I don't see a strong reason.
Okay, yeah, I write some text to the mailing list. Thank you so much for the feedback.
Thank you, Kaname.
Yeah,
Your
thank you.
hackathon activities is amazing. Thank you for doing this.
Thank you.
So the next is about the current status of working group documents that have a common set of authors. So Thiru will
Yeah.
provide an update.
Yeah, this should be easy because most of the drafts are. Yeah, thank you. I'll give an update on various working group documents and their statuses. The first one is .server discovery. We have done a couple of revisions to the draft after the last IETF, and we have addressed all the comments received from the working group, mainly to integrate call home so that the call home dots client could be discovered by the call home dot server, and added illustrative examples on how an agent which is acting as both dot server and call home dots client can be discovered by the dots client and the call home dot server. And we fixed some normative languages and some dangling text. And both the signal and call home IDs have been moved to informational, because an implementer can just implement the dot server discovery without going through those drafts. And then we have added explanation on multiple IP addresses that could be returned by the DHCP server, so that it can act as a both primary and secondary servers in case if the primary cannot be reached. DOTS signal channel already discusses happy apples mechanism for establishing communication with DOTS server. So the draft does not go into details on how to establish communication with the DOTS server. The working group last call is over, and we are waiting for Shepard write-up for the draft. Dot signal call home had got good review comments, especially for adding tests to avoid conflict with what dot signal channel does, and we have added call home reference architecture with new terminology to avoid confusion with the base signal channel. And we have also integrated all the working group lost comments received, and the draft is also waiting for write-up. We have not received much feedback from the working group on this draft, and we would request more comments on this. One of our co-authors, Vipen, had sent us offline comments. We'll fix that and post a new revision. But we'd really ask for more feedback on this draft from the working group. I think we are
going to issue an update for this draft
Yes, we will do it.
because it haven't been updated for
Yeah,
quite a
we
while.
will do that in the next month. Yeah.
Okay, thank you. So I think it's one of the most interesting parts of our today's.
Yeah, we've been working on this for the last, trying to follow up with Carsten for this and Ben and others for this, because we were not sure what is the alternative mechanism, but in the last few weeks, we made significant progress on this. Thanks to all the help from Carsten, especially. Just a quick recap on what happened, right? I mean, the draft was approved by all the ISEC members, but the transport AD, Mircea, had an objection to the way we were using QAP ping. QAP ping had certain disadvantages, that it was using confirmable messages, which would cause exponential retransmissions. And that was something that the working group had picked that at that time, because there was no way for the dot server at least to send request messages back to the client, and QAP ping was the only message we thought that the server could send back to the client, and that's the reason we had picked QAP ping. But it was under the full control of the DOTS application by both the DOTS client and server, and we had a very vanilla behavior where the client was acting as QAP client and the DOTS server was acting as a QAP server, and our transport AD had objections to that, and we were not sure what the alternative approach could be. Right, but the recent interaction with Carsten and the QAP library like libQAP we've been looking into indicated that the DOTS client can behave as a QAP client, and it can act as both client and server. Similarly, the server can also act as a client and server. So it means that the DOTS server can now send requests back to the client, and the client can now respond to requests coming from the server. So with that in mind, it was pretty evident that we could easily move away from the confirmable QAP messages to DOTS level non-confirmable messages. So in that context, what we have done is we have updated the draft to say that the behavior of the client with regard to QAP client continues to stay for all the DOTS mechanisms, including the DOTS heartbeat operations, where for DOTS heartbeat operations, the client acts as both client and server, and similarly, the server acts as both client and server. So in that regard, the feedback that we had received with this was pretty easy, that all that we had to do is define a new dot specific heartbeat request. We have introduced a /HP as the URI suffix for the heartbeat request, and we have added peer HP status, an attribute within that request. I'll go into the details why we had added that. As I've already explained, it's going to be non-confirmable message, and which gives us more control with regard to the periodic transmission of the DOTS heartbeat messages. And one of the feedback that we had received from Carsten is initially we wanted to go with GET, but Carsten suggested that since GET would not influence the application state, it would better be to pick either put or a post. So that's the reason we picked put. And the other reason was the peer heartbeat status is a good way of indicating back to the peer dots agent whether a heartbeat requests are coming from the peer agent or not. So that way, the peer agent could basically change the way change the frequency with which it is sending heartbeat requests to the to its peer. So in that regard, the other feedback that we had received was if you are sending requests without any responses, then CoAP has a message transmission parameter called probing rate, which is basically set to 1 byte per second. And constant suggestion, but the flexibility is applications do have a control on what value to pick. And so that's the reason probing rate can be negotiated during the peacetime between the dots agents, similar to other message retransmission parameters. And further to add, avoid interfering with the mitigation requests. Mitigation requests today already follow the UDP transmission guidelines defined in RFC 8085. So if the round trip time is not known, then mitigation requests are not sent more than 3 seconds per. Just only one mitigation request is sent per the 3 seconds. So with that, the dots mitigation requests do not need to follow the probing rate, and they would continue to follow the message transmission guidelines given in RFC 8085. But however, for the dots heartbeat requests, we wanted to make sure that it follows the probing rate that was defined in the CoAP. So what we have done is we have come up with a couple of algorithms to define what would be a reasonable probing rate, assuming we want to send the probing rate at least every 30 seconds for both liveliness checks and to keep the NAT banding alive. So that's the reason we had come up with a simple formula where you would use heartbeat interval and probing rate bytes to figure out what would be an ideal value for the probing rate, and that's the value that the client can calculate and pick for its heartbeat requests.
Benkita, so can you go back to the previous slide, please? So I just wanted to double check. We have this new text which is talking, you must not apply other congestion control checks. And I think from what you were saying when you were talking about that we have some exterior limit about you can't send more than one of these every 3 seconds to start a new mitigation request.
Yes, so that text is already there in the draft.
Okay, good, because if we just had this new text, that would be kind of still problematic from the transport side.
We have very clear text saying it's a normative text saying that we must follow the transmission guidelines given in 8085 and we should not exceed that.
Excellent.
Yeah,
great.
Yep, and then and internally, right, beyond the way the heartbeat messages are exchanged, the way the client and server logic would be there to make decisions with regard to the heartbeat missing number of heartbeats allowed, there wouldn't be any change in that. So it's mostly a change with regard to the negotiation of heart probing rate, but the internal underlying implementation for detecting whether the peer is alive or dead is not changing with this approach. And thanks to all the feedback and the help we got from Kanabe and John, I think some initial testing shows that this new mechanism is working, and we believe this issue is resolved. And we already sent a mail to Mirja already, and probably review from our AD and chairs would help us to progress this, and from the working group as well to quickly close this issue.
Just clarification question, and new headbeat mechanism, is there some interaction if reliable channel is used like TCP?
Yes, for reliable channel also we are using the same dots heartbeat message, but it's just one message, and the underlying TCP transport would take care of retransmissions. Okay. So probing rate would not be applicable here.
So is it reflected in the draft?
Yes.
Okay, thank you. So, well, next steps, and I will ask our AD what to do in this situation, because there seem to be some substantial changes to the draft, and the draft is already in at ISG evaluation. So what shall we do?
Right. So I have been talking to Miria throughout this week about the proposed changes and how they will look. So I believe that she should be able to reballot soon. And then because we did make some fairly big changes to how things work as a result of the ISG review, I think it's probably a good idea to do just like a short 1 week working group last call on the changes, since the 31, I think, is what we did the IETF last call. Now we're on the 39. So just to get a quick sanity check from the working group that this still makes sense and works for everybody. But I don't think we'll need to do another IETF last call or something like that.
Okay, so you will return the draft back to working group. We will issue last call and then request a publication again.
No, I don't think we need to do that. I think I can just hold it.
issue last call in the working
Yeah,
group.
just
Okay.
issue the last call.
Okay. Thank you. So, well, I think we'll issue last call probably in a week, just to have all the people return from IETF and all the Thanksgiving Day holidays passed. So in the beginning of December, about the same.
That would be
Okay.
great. Thanks.
So the next is about telemetry draft update.
Thanks. I will be presenting updates to the DOTS telemetry draft. We have made significant updates to the draft from the last time I had presented this at the last IETF.
It must be.
Yep. So what we have done is we have addressed all the comments received between 01 and 04 actually addresses all the comments received from the working group, and it also integrates integrates the work that Mei-Ling has been doing in her other drafts. So we have discussed offline with her and picked pieces which was which at least the working group had consensus regarding the attack details, and that was the portions that were updated into the draft. I'll explain the changes that were done to the draft. As a quick reminder, DOTS telemetry was discussed in the working group. I mean, when the working group was formed, at least that it's probably, but at the time it was decided that it's an optional piece of information and need not be taken up immediately. So we published this draft after most of the base protocol drafts had progressed. And it's basically a collection of attributes characterizing both the normal baseline behavior and the attack characteristics. And both are useful for DDoS detection and mitigation, especially for statistical analysis, machine learning, or deep learning techniques. DOTS telemetry is an optional set of attributes as defined in the DOTS requirements, and it can be signaled in both signal and data channel protocols.
Wei Pan from Huawei. Quick question. I asked you before about whether to use data channel to convey the DOTS telemetry, and your response was to just use the DOTS signal channel. And do you change it to that now?
We have not done any changes, so I don't want to use two protocols for the same information, so we should pick one of them, basically, right? I mean, there's no point in using two protocols to signal the same telemetry, but I would ideally like to. I would like more discussion on whether DOTS signal or data channel is appropriate for signaling the DOTS telemetry.
Okay. Yeah.
So Valery Smyslov from the floor. I have roughly the same doubt. Well, my doubt is that you're using signal channel for transferring additional information, but in case of attack, signal channel will probably be saturated, and mitigation request is much more important information. So if you add an additional bandwidth, if you use signal channel for transferring more information, the probably more important request to mitigate an attack will get lost. So
Yeah, so it's more of a problem, especially during the attack time, right? And during attack time, DOTS data channel is not supposed to work, right? DOTS data channel is not designed to work. And if you see the telemetry that we are discussing here is a separate request. It can either piggyback a mitigation request, or if the size exceeds, it can be always sent as a separate request. So it need not be tied to the mitigation request, because that's the most critical one. The normal during peacetime, I think we can send the DOTS telemetry either using the signal or data channel. That's not the problem. But during attack time, when you have lots of attack traffic coming and the link is saturated, the only way you can convey the attack details is using the signal channel, and we don't have an option of using the data channel.
I just think that the traffic must be prioritized, so the mitigation request is much more important than telemetry.
Yes. I think that's a good comment, and we'll update the draft. Thank you. Yeah. So as Kanabe was presented, a path suffix / telemetry was added, but I agree with him that this probably needs to be split into any telemetry which is more of a baseline and less frequently changed versus telemetry which could frequently change based on the attack characteristics. So this is something that we have updated the draft to discuss. The draft was previously focusing mostly on bandwidth consuming attacks, but nowadays we see a large increase in resource consuming DDoS attacks. So we have added various baseline behavior with regard to resource consuming DDoS attacks that the client can signal to the server. It could include various parameters like max number of simultaneous connections allowed to the target, max number of simultaneous connections allowed to the target server per client, in case if a client is bombarding the server with the various DDoS attack connections. Simultaneous embryo connection refers to half open connections, because we have seen various DDoS attacks where just the client establishes half open connections, just sends in packet but does not respond to the SYNAC coming from the server, and it just wastes the CPU cycles and the memory cycles of the server to basically process these and store a state for these half open connections. And similarly, the other properties like max number of embryonic connections that are allowed per second, the number of max number of connections allowed per second to the target per client. And this is at the transport layer, and we also have attacks at the layer 7. And if you see the recent trends, the attacks at the layer 7 have increased drastically with regard to with regard to slow Laris attacks, where the client just sends garbage data or partial requests, so that the application server would just store that partial request expecting the rest of the data to arrive, and that just consumes the memory of the server so that it cannot process legitimate requests coming from other clients. And that's a pretty new technique that has come up, and it's going to be pretty challenging, especially with HTTP 2.3 and HTTP 2. So these parameters discuss the max number of requests allowed per second to the target server, max number of requests allowed per second to the target server per client, and the max number of partial requests allowed per second to the target server, and the max number of partial requests allowed per second to the target server per client. And with regard to the same resource consuming attacks, the percentile values of low, medium, high, and peak of simultaneous attack connections to the target server, number of simultaneous embryonic connections to the target server, and attack connections per second, and attack requests to the target server. I mean, we're missing a couple of attributes here with regard to attack requests to the target server per second and attack connections per second to the target server. So we'll fix this, and I've raised issues in the JIT already. So we need more feedback from the working group on to get a complete list of attributes that we think are required to for these especially resource consuming DDoS attacks. Attack details had received several feedback from the working group, especially with regard to the attack details being signaled from the dot server to client, which was not there in the original draft, and we have updated to add that with an example on why that would happen, just like Kanabe had explained. And we have also updated the attack details in very similar way that products use it today with regard to the start time of the attack, the end time, and percentile values of sources involved in the attack to understand the number of attackers involved in this, the scale of the attack, basically, and whether to know whether it's a bandwidth or a resource-consuming attack and the corresponding attributes per attack. The worst case, it could be both bandwidth and resource-consuming attack, and that could also be signaled. And the list of top talkers targeting the victim and the attack traffic from each of the top talkers. One of the important parameters that was added is whether the top talker is a spoofed IP address or not. If it's a spoofed IP address, you cannot put an ACL rule and block the traffic because that would penalize legitimate traffic, right? Imagine somebody using 8.8.8 to send DNS spoof responses. You don't want to block traffic from 8.8.8 because that would block all good traffic coming. So identifying spoofed IP addresses is very important so that legitimate clients are not penalized. And further, the bandwidth or resource consuming DDoS attacks and corresponding attack attributes per target. We also have a configuration parameter where the client and server can negotiate the configuration parameters for telemetry data, the low, mid, high, and peak values. And we have recently added an ANG module in the version 3 and the CBOR mapping registry for DOTS implementation. One of the major questions, I mean, the comments that we have not yet addressed is where do we draw the line, basically, right? Especially during the attack time, we know certain attributes can only be sent using dot signal channel. But now during the peacetime, do you want to use the dot signal channel or do you want to use the dot data channel, right? We just picked on the dot signal channel because dot signal channel also allows confirmable messages, and CoAP is also used nowadays for configuration purposes. So whether we want to use dots signal channel during the peacetime for sending the dots telemetry is a question for the working group. And I think both the protocols can do the job here. It's just that we have to pick one. And but at least during the attack time, any attack details that can be sent can only be sent using the dots signal channel. And we would like more feedback on any other configuration parameters other than percentile that can be negotiated between the client and server. And I think we have been receiving lots of comments and we've been trying to address that. And we see a lot of interest in this draft and we will request for working group adoption.
Thank you. So how many people read the draft? Okay. I think there is some interest in the group for this draft. We can, I think we can make a harm for adoption and then confirm it in the list. So, well, let's, if you are in favor of adoption of this draft as a working group document, please hum now. In favor? Yes. Let's try again. If you want this document to be adopted, let's come now. It's louder. If you don't want this document to be adopted, please come now. No voice. So I think that the feeling in the room that the document should be adopted, but we will confirm this in the list. So thank you, Tiro.
Thanks.
Okay, thank you.
Okay.
We have one more presentation regarding telemetry use case.
Yes. Thank you, Chair.
Yes.
Okay, thank you. I'm Yuhei Hayashi from NTT. So I will show use case of those telemetry use case named efficient use of DMS based on traffic bandwidth. This is summary of presentation. We carried out POC about efficient use of DMS based on traffic bandwidth. And we assess that DOTS telemetry spec, especially YAM module related top talker and bandwidth can be applied in the use case. So this slide is assumption of use case. A network provides a DM service to subscriber, and some network equipments are deployed in the network to provide the service. Routers, which can send net flow, and flow collector, which can detect DDoS attack, and DMS, which can mitigate DDoS attack, and selector, which can accommodate appropriate DMS, and finally, orchestrator. And volume DDoS attack to DMS service subscriber is carried out by attackers to subscriber. And at this time, bandwidth of attack traffic destined to target is more than available capacity of DMS. Then, flow collector detects attack and send attack report to orchestrator. And the attack report includes bandwidth to tuple flow. This is the assumption. And this is a use case scenario of ours. And this use case POC was carried out in our laboratories. And I want to explain this scenario. Orchestrator carries out some process, first receiving attack report and checking the duplication, and register the bandwidth of two tuple flows, and check available capacity of DMS, and check if this IP is DMS service subscribers 1. And then orchestrator redirect attack flow to DMS. If DMS available capacity is more than this IP flows bandwidth, orchestrator redirects all of this IP flow to available DMS. On the other hand, DMS available capacity is less than this IP flows bandwidth. Orchestrator redirect two tuple flows of top talker preferentially. And network operator can use available capacity of DMS efficiently by using this scenario. And we assessed that current DOTS telemetry can be applied to the use case. This figure shows that a YAM module related to top talker and bandwidth, and the right one is a rollover orchestrator. Theoretically, the YAM module related to top talker and bandwidth can be applied to the use case. Yes. My presentation is end.
Thank you.
Yeah, Kanami Nishizuka from NTT Communications. One clarification question. So you need the bandwidth information of tuple of destination IP and source IP, right? IP address, right? So, sorry, back to the previous, that one. So in order to convey that information, you will use the pre-mitigation module, because it only includes the target IP and the source IP address of it, right? So
Yes, that's right.
yeah. So attack detail is not enough because it only includes the destination IP address. Right. Okay. Sorry, source IP address. Right.
Yes, that's right. Thank you.
Kanabe, I didn't get that comment. I think the telemetry includes both the target and the source of the attack. So both the attributes are present. If you see the telemetry, it has both the target, the victim of the attack, and the source source prefixes and the source details who is attacking the target. Both the tuples are present.
Okay. This is like I just thought mitigation scope. includes the target IP address, and then source address is included in attack detail. However, UHE requires the bandwidth of couple of destination IP address and source address, and the mitigation scope only includes the group of IP address. However, he requires each source IP address and each destination IP address. So he will separate. He will need the array of those metrics, which includes one source IP address, one destination IP address, and the
Please speak to Mike.
and the bandwidth of the.
Instead of duplicating that, the other way could be that you could send a mitigation request per target, basically, rather than grouping them.
Ben Kaduk. So on the slide, it talks about the tuple of the source and destination IP addresses. And then Kaname was just talking about maybe you have the source prefixes. So do you have a sense for how much coalescing there is between source IP addresses of the attack into having just a source prefix? Because if we need to always send the source IP address, then it might be a very large amount of information.
That's a good question. So my assumption is that send only top tokens to tuple flow, and so my sense maybe 1,000 or 100 or 1,000. So use DMS capacity so efficiently. Sorry, I don't have the concrete the number of.
So to Ben answer your question, I mean, if it's a large-scale DDoS attack, it would be a group of source prefixes that would be launching, and they would be the top talkers. It's very difficult to identify just 10 top talkers who could basically bring down a large server, basically. So yeah, it has to be a group of thousands of malwares which are coordinating a Meraki kind of an attack, and that would be a prefix range coming from a specific geography, because malwares typically start with a specific geography and then they move across to other geographies. So
Thank you.
Any more questions? Comments?
I want to say that the use case for the DOTS telemetry, such work is very useful, and to validate whether the DOTS telemetry is needed or complete. And I'd like to raise another discuss or use case about how telemetry can be used. Imagine we discussed whether to use the signal channel at for telemetry at the attack time. So at attack time, the both signal channel and day channel may first day channel won't work as we designed it, and the signal channel may also can not be useful. So those telemetry can be used before the attack to convey some the normal traffic baseline information to the server, and the server can observe the traffic, but it may not be able to judge whether the attack is happened on the client. But with the telemetry information, with the baseline information, and the client, the server can compare the current traffic with the baseline, and to judge there is a attack, and then there is no need to send all the mitigation requests failed to be received by the server, but the server can still arrange a mitigation for the client. Yeah.
Just a second, your name.
Wei Pan from Huawei.
Okay, please say your name when you comment.
Thiru, so if you see the telemetry, right? Telemetry can be still sent during the peacetime. For example, the baseline and the capacity one, like we discussed in the draft, can be sent during the peacetime, and that's the recommendation. If the text is not there, we can definitely add that, but the recommendation is to send the baseline traffic, and the capabilities of the DOTS server, like how many connections it can handle, all that can be sent during the peacetime. The only one that is mandatory and required to be sent during the attack pre-mitigation or attack time is the attack details. What kind of attack you're seeing? Is it a resource-based one? What is the scale of the attack? And only that can be sent during an attack time.
Thank you for comments.
One more thing. Do you consider to write a draft about the use case of DOTS telemetry, or just try to integrate it into the current draft?
Yes. So I would like to write DOTS telemetry use case draft, and so I have several telemetry use case other than this use case, and maybe other operator company he has telemetry use case, and I want to them to be closer and to describe the use case about DOTS telemetry. Yes.
Actually, as a chair, yes, it's a good thing to do. We encourage you. Sorry, my throat. But if you really want to propose use case, please be quick, because we're already on the document, on the draft, on the solution draft, and actually they also include some use cases in the solution draft. So we'd like to see, is there any different use case from your side, or you have the same concern with the current solution? So it's more quick is better. Okay.
Yeah, Thiru here, I agree. I think we need to list all the possible use cases so that we can basically go back and check if the DOTS telemetry is meeting those use cases or not. And unfortunately, the original DOTS use cases does not talk about telemetry, so we definitely need a DOTS use cases for telemetry.
Well, as a chair, I think that it's probably worth to think if to include use cases in the telemetry draft, because it's always easier for reader to first look at the use cases and then look at the solution. It depends on the number of use cases. Probably we need to judge whether we need a separate document or just to include an additional introduction section describing the common use cases for the telemetry.
Yeah, it works for me. I mean, whatever the working group decides. But
Well,
let's start collecting all the use cases in one doc, and
yes,
whether when it's the right time we can make a call whether to merge or keep them separate. Yeah.
It depends on the number of use cases, and of course it's the working group to decide.
Yeah, I mean, if it's like a 40-50 page use cases document, you don't want to merge that, right?
But if it's just a couple of pages, it's okay. So, thank you.
Thank you.
So the next topic, it seems that, well, where is it? Okay, it seems that we have some new items compared to the original charter of the working group, and just for the formal purposes, we probably need to update our charter by including them into charter. So it's and these documents are partly already a working group document, for example, like server discovery and signal call home. And I think that it's probably worth to update our charter just to reflect what we are doing. And it's not a big update. It's currently just adding a couple of working group items that we are working on. So I'm again asking our AD, what do you think? What does he think?
Ben Kaduk. Yeah, so I was actually looking at the charter yesterday or the day before, thinking about the new milestones, and I agree that we should have a little bit more clarity in the charter about what we're working on. Right now, it's a little bit ambiguous. So I think it's probably worth going forward with the recharter.
Okay, then I think our steps are to send a new charter to the working group, and if everyone agrees, then send it to you and you'll approve it. Okay. So I think we've through our agenda. Any questions, comments, any other business? So we've done. So thanks to everybody. We wish a quick recovery to Frank with his voice.
This is Friday. Maybe someone. Thank you. Thank you. Thank you for taking all of